Chemical properties of metals. Before starting the lecture, click on the subscribe button and get access to our 100 of conceptual lectures for free. Now, what are the 5 chemical properties of metals? Well, the first chemical property of metals is reaction with oxygen. Metals react with oxygen to form metal oxides. Metals like potassium and sodium react vigorously with oxygen. For example, potassium reacts with oxygen to form potassium oxide. Sodium also reacts with oxygen to form sodium oxide. Secondly, metals like magnesium, aluminium, and zinc also react with oxygen. For example, magnesium reacts with oxygen to form a magnesium oxide. But this magnesium oxide forms a thin protective layer and protects the inner parts from oxidation. Thus, magnesium, aluminium, and zinc form a thin protective layer of oxides. Thirdly, less reactive metals like gold and silver do not react with oxygen. Remember that metals usually form basic oxides. Basic oxides mean oxides that are basic in nature, or basic oxides turn red litmus paper into blue. But metals like zinc and aluminium form amphoteric oxides. For example, zinc oxide and aluminium oxides are amphoteric oxides. Amphoteric oxides mean oxides that have both acidic and basic nature. So note it down that metal react with oxygen to form metal oxides. The second chemical property of metals is reaction with water. Metals react with water to form metal hydroxide and hydrogen gas. Reactive metals like potassium, sodium, and calcium react with water. For example, sodium reacts with water to form sodium hydroxide and hydrogen gas. Also, calcium reacts with water to form calcium hydroxide and hydrogen gas. Secondly, metals like magnesium and zinc do not react with cold water, but they react with hot water to form their respective oxides. For example, magnesium reacts with hot water to form magnesium oxide plus hydrogen gas. Thus, remember that metals react with water to form metal hydroxide. The third chemical property of metals is reaction with dilute acids. Reactive metals like sodium, potassium, and calcium react vigorously with dilute sulfuric acid or dilute hydrochloric acid to form their respective metallic salt and hydrogen gas. For example, sodium reacts with dilute hydrochloric acid to form sodium chloride and hydrogen gas. This sodium chloride is a metallic salt. Also, calcium reacts with sulfuric acid to form calcium sulfate and hydrogen gas. Here, calcium sulfate is a metallic salt. From these two examples, we also learn that when metals react with acids, they form metallic salts. The fourth chemical property of metals is reaction of metals with other metal salts. Metal salts means salts like sodium chloride and copper sulfate. Metals that are more reactive displace the less reactive metal from its oxides. For instance, zinc is more reactive metal. Copper is less reactive metal. Now consider a metal salt of copper like copper sulfate. If I add zinc to the solution of copper sulfate, I will get zinc sulfate and precipitate of copper. Here, zinc, being more reactive metal, displaces the less reactive metal, copper, from its salt. That's why we also call this reaction as displacement reaction. Thus remember that more reactive metal displaces less reactive metal from its salt. The fifth chemical property of metal is reaction with hydrogen. Remember that only few reactive metals like potassium, sodium and calcium react with hydrogen to form metal hydrides. For example, sodium react with hydrogen to form sodium hydride. Potassium react with hydrogen to form potassium hydride. Therefore, we say that very few reactive metals react with hydrogen to form metal hydrides. This was all about the chemical properties of metals.
Chemical properties of non-metals.
Now, what would happen if we got some non-metal like carbon and got it to react with oxygen? I'd like you to pause for a moment and try to guess this. Well, we would get carbon dioxide, right? Okay, what if we took something like sulfur and got it to react with oxygen? We would get sulfur dioxide, right? Now, the interesting thing about sulfur is that this sulfur dioxide can further react with oxygen to give sulfur trioxide. So with sulfur, you have two different types of oxides. You have sulfur dioxide as well as sulfur trioxide. Well, if you're wondering why it's possible to have two different types of sulfur oxides, that's because sulfur can show two different types of valencies. Okay, before we move on, I'll just balance this last equation so that it's perfect. Okay, now as we proceed, let me ask you this question. What would happen if we added water to these non-metallic oxides? Like for example, with CO2, what if I added water? What happens? Well, we get an acid, and this acid is called carbonic acid. Okay, what if I did the same thing with SO3? I would get another acid. This one is called sulfuric acid. I'm sure you've heard about this, H2SO4. Okay, and the key thing that I want to point out is that we're getting an acid when we add water to, or get water to react with a non-metallic oxide. Okay, let's summarize. Remember how with metals we had metals reacting with oxygen to give metallic oxides, and then metallic oxides reacting with water to give bases. What about nonmetals? Nonmetals react with oxygen to give non-metallic oxides, and when you get them to react with water, you get acids. Now, I'm sure you know this already. Acids have the ability to turn blue litmus into red color, right? Okay, so that was about the reactions of metals and nonmetals with oxygen, and then their oxides with water.